Hello, thank you for watching this video. So on this video, we'll be doing question 9 of May, June 2023, question paper mathematics paper 1. And this is the application of calculus, which is the optimization, I think. So I'll read question 9 statement and then answer the questions that follow. So let's go. They are saying, a wire 12 meter long is cut into two pieces. One part is bent to form an equilateral triangle, and the other a square. A side of a triangle has a length of 2x meters. Let's read this thing again. A wire 12 meter long is cut into two pieces. One part is bent to form an equilateral triangle, and the other a square. A side of a triangle has a length of 2x meters. No problem. So now we're doing 9.1. Write down the length of a side of a square in terms of x, right? So they want us to write down the length of a side of a square in terms of x. No problem. So we have a wire here. Here is this wire. It's 12 meters long. No problem. So it is cut, this wire of ours, such that we form an equilateral triangle. What is an equilateral triangle? It's a triangle in which all sides are equal. And the other, let's say this side here, and the other side, the remaining side, which is this part, is used to form what? To make a square. What is the square? It's this thing with all sides being equal. This is your square, this is your triangle. So you are told that each side, a side of a triangle is 2x, which means we know this one is 2x as well, and this one is 2x as well. That's what we know. So the total length of the triangle, so the length of wire used to form this triangle is equal to 2x plus 2x plus 2x. So this, to form this triangle, we use a total of 6x meters. This is the total length that we used. So which means the part that we did cut out here, this part that we did cut out here, is 6x meters. Then, in total, this part here, it was 12, right? But from the 12, we remove 6x to form what? To form a triangle. The remaining thing will be that 12 meters minus 6x, which is the part that we have cut off to make the triangle. So, the perimeter, which is the total length of this square, is 12x minus 6. Because, I'm saying this because we said this is we did cut the wire, right? Such that we form this equilateral triangle, which is all sides are equal, and the square, which is that. So, we know that the equilateral triangle, each side have a length of 2x, because all sides are equal. We're told that we're given that one side is 2x. So the total length used to make the square, to make this equilateral triangle, will be the sum of these sides, which is 6x in total. That is the length of the wire used to form a triangle. No problem. Then, now, what is remaining here? It will be that 12 meters minus 6x, which is from the 12 meters, from the total length of the wire, you remove the 6 meters that is used to form an equilateral triangle. Right? So you are left with that. But this length is also used to make a square. And you know a square, all sides are equal. So this will be divided equally so that it forms all these sides. So it forms a total of 4 equal sides. So now the length of each side, the length of the wire that is used to make the square, the total length of a wire that is used to make the square, it will be what? 12 minus 6x, which is the total length of the wire that is used to make the square is 12 minus 6x, right? And what else do we know? What we know is that now we use this amount of length of wire to make a square, and the square have 4 sides. How much does each side may take. So now, to get what they're asking for, which is the length of a side of a wire, of the length of a side of a square, length of a side of your square, length of a side now, it will be your 12 minus 6x, all divided by 4, because you will divide this total length of the square 4 times so that you can make 4 equal sides, which means now it's more like you have this. Let me just leave it there. It looks nicer there. So this is your let's just say 9.1 here. 9.1. So your length, which is what they asked you, each side of the square will have this amount of length. No problem. Move to the next one, which is 9.2. What are they saying? Okay, now, so we're going to do 9.2. They're saying, if this square is now used as the base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. Let's read this thing again. So, if this square is now used as the base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. So now they're saying this square is used as a base of a rectangular prism. What is the base? A base is more like a foundation, like it's from, if you're going to form your rectangular prism. So your floor, let's say now I want to build, this is not a square, of course, this is a paper, right? So let's say I want to, this paper resembles the shape of a rectangle, right? So if I want to form a rectangular prism, which means now I just need the third dimension, which is the height here. So this rectangle here, right? This rectangle here will form a base of my triangle, which is the floor of my rectangular prism. That's what they're saying. They're saying now this thing here, our square, which is that, forms a base of a rectangular prism. So I will try to draw it, but I'm not good at drawing. So let's say let's think of all these things as equal. So this is the base of a rectangular prism. The length of this side is 12 minus 6x all over 4. And this side is 12 minus 6x all over 4. So now this is the third dimension, actually not the third, no. So this is the height. So we are told that the height of this thing is 4x, which is the height of this cube of yours. So your square, the base is what is sitting on the floor of the rectangular prism. A rectangular prism looks like this. This is a sort of some rectangular prism, like an ice cube, not ice block, not ice cube was the cube, but it's similar to that. So now, they want the maximum volume. You know how to calculate the volume of a rectangular prism. Volume of a rectangular prism is equal to length times breadth times height. So your volume is equal to your length. What is your length here? Is your length here? So it's 12 minus 6x all over 4 times breadth. What is your breadth? There is your breadth. There. It's also 12 minus 6x all over 4 times the height. What is the height? Your height is 4x. So your volume is a function of x is equal to, let's simplify this. So you can say this and that. Actually, this should be 4x, not just 4. We're left with x there. So multiply this times that, you will have maybe 144. Let me use my calculator so that I don't make a mistake. Because you will have, you multiply these brackets out, so it will be 12 times 12, this times this, also this times this times that. So you have 12 times 12, right? which will be 144, no problem. Then what else do we have? So you have this times this. So you have minus 144x, and then you have plus 36 x squared times x, all divided by 4. This is what we have now, right? And then we can say now, you can multiply by this in here. So v is a function of x is equal to 144 x minus 144 x squared plus 36 x cubed, all divided by what? All divided by 4. So v is a function of x equal to 144 x over 4 minus 144 x squared over 4 plus 36 x cubed over 4. That is what we have, right? No problem. So v is a function of x is equal to the 144 divided by 4. So we have 36 x minus 36 x squared plus 9 x cubed. So because we want the maximum volume, we derive this equal to 0. V prime is function of x is equal to what? It's equal to 36 minus 72 x plus what? Times 27 x squared. That's what we have. Equated to 0. So we have 36 minus 72 x plus 27 x squared. Then solve for x. Your x is equal to negative b plus or minus square root of a discriminant all over 2a. So for your x is equal to negative what? B. What is your b? Your b is minus 72 plus or minus the square root of minus 72 all squared, right? Minus 4a, this is our a, is 27. C, what is our c? It's 36 all over 2 times a, which is 27, I think. So x is equal to, let's go. So negative b, which is negative 72, plus the square root of negative 72 all squared, minus 4 into a, which is 27, c, which is 36, over 2 into 27. So get out your x is equal to 2, or your x is equal to 2 over 3. These are the values of x. You want them to give you the maximum volume, right? So you determine the maximum volume of the rectangular prism, right? So if you look at this, thing here, this volume is defined by a cubic function, and this cubic function will have a shape like this, right? So it will have a local maximum at the first turning point, which will be what? 2 over 3, and the minimum there at x is equal to 2. So I think we'll get the maximum there. So let's substitute that into our volume, which is that. So our volume at 2 is equal to, which is this, 144 times at 2 over 3, actually, not 2. It's equal to 144 into 2 over 3, right? Minus 144 at 2 over 3 squared plus 36, 2 over 3 cubed, all divided by 4. So your function at 2 over 3 is equal to whatever this is. So I'm saying, okay, that the minimum will sit here, not there, because you can see that this is defined by a positive cubic function, which will have this shape here. So the maximum will be at the first turning point, which is this. So this is so you can see what we get. So we have 144 into 2 over 3, right? Minus 144 to 2 over 3 squared plus 36 into 2 over 3 cubed 1 over 4. So we get that our volume is 32 over 3 square meters, or 1, say our volume at 2 over 3 is equal to 10.67 square meters. I think if you substitute 2 there, you will get a smaller volume than this, because this will be sitting at a lower position. So when you substitute your 2 over 3, you get this is your answer in cubic square meters, right? And then if you substitute your 2, you get that your volume at 2 is equal to 0. Like we expected that this would be a minimum point. So this is your maximum volume of your rectangular prism that have a height of 4x and a base of this square of ours, which have a length of that. So I'm done with this one, and I hope it does make sense to you as it does to me. Thank you for watching. Cheers.